Hello guys, welcome back to my YouTube channel. Today we have this beautiful rational exponential equation before us, and then we are going to look at the value of a that will satisfy this rational exponential equation. So let's see how we proceed with this problem. But before then, please subscribe to my channel if this is your first time coming across my YouTube channel. I welcome you to my channel, and then if you are a returning subscriber, please like my video, share it, and leave a comment in the comment section. Thank you very much, and let's begin. So first we write down our solution, and then we have the question: 16 to the power of a plus 4 to the power of a plus 1 divided by 4 to the power of a plus 2 to the power of a plus 1 equal to 3. So what I'm going to do is to look at the left hand side and then consider the terms in index form. So, and then looking at both the numerator and the denominator, you can see that we have the lowest common base of 2. So we're going to write 16 to the power of a, 4 to the power of a, and 4 to the power of a in base 2. And so I'm going to have 16 will give me 2 to the power of 4, all to the power of a, plus 4 will give me 2 to the power of 2, all to the power of a. Then of course I have my plus 1 divided by 2 to the power of 2, all to the power of a, plus 2 to the power of a, plus 1, all equal to 3. The next is to apply this rule of index, where we have a to the power of m, all to the power of n, will become a to the power of mn, which can also be written as a to the power of n, switching the m and the n, all to the power of m. So you can see the transition, the switch there, the reversal that has taken place. So in that case, applying this simple rule of indices to both the numerator and denominator of this question, I'm going to have 2 to the power of a, all to the power of 4 now, plus 2 to the power of a, all to the power of 2, plus 1, all over 2 to the power of a, all to the power of 2, plus 2 to the power of a, plus 1 equal to 3. Now, the idea why we have to apply this law is so that all the index notation will be in the same power, the same base and the same power, okay? So what we now need to do is to say, let 2 to the power of a represent x. So in that case, the equation now, both the numerator and the denominator of the equation becomes x to the power of 4 plus x to the power of 2 plus 1 all over x to the power of 2 plus x plus 1 equal to 3. So here we apply the cross multiplication rule for fractions. So we have x to the power of 4, plus x to the power of 2 plus 1 equal to 3 open bracket x to the power of 2 plus x plus 1. So we're going to have, we open up the bracket, expand the bracket on the right, x to the power of 4 plus x to the power of 2 plus 1 equal to 3x squared plus 3x plus 3. Now we collect all terms so that we have an equation of degree 4. So we have x to the power of 4 plus x squared plus 1 minus 3x squared minus 3x minus 3 equal to 0. So x to the power of 4 plus, so x squared minus 3x squared will give us minus 2x squared. So we have minus 3x. Then of course 1 minus 3 will give us minus 2, all equal to 0. So we need to find the factors of the left hand side. So how we do that is to, since this is a polynomial of degree 4, so I can say now, I'm going to say let f of x represent equal to 4, x to the power of 4, and then minus 2x squared minus 3x minus 2. So this is a function, a polynomial function, and so we're going to now find the zeros of this polynomial. Find the zeros of f of x. We'll find the zeros of f of x. So we're going to find the zeros of f of x. Okay. So what we need to do now is to use a method of finding the zeros of f of x. So we're going to do a kind of trial and error. So where I will use x plus or minus 1, x plus or minus 2, x plus or minus 3. So let's start with the first factor. Let's say we want to find, let's say which of the, okay, let's try x plus 1 equal to 0, and that would mean x equal to minus 1. So let's find f of minus 1. If f of x is 0, if f of minus 1 is equal to 0, then f of x, then x plus 1 is a factor of, if from our solution, if f of minus 1 is equal to 0, then it means that x plus 1 is a factor of f of x. So let me move over to the next page. So what we need to do is to substitute. I'm going to have my, so I need to find f of minus 1. F of minus 1 will give minus 1 to the power of 4. Then of course, minus 2, open bracket, minus 1 to the power of 2. Then of course, minus 3, open bracket, minus 1, then minus 2. So this will give 1 minus 2 times 1, then plus 3 minus 2. So we have 1 minus 2 plus 3 minus 2. So we have 1 plus 3 minus 2 minus 2. So this will give us 4 minus 4, which is 0. So f of minus 1 equal to 0. Therefore, x plus 1 is a factor of f of x. So since we have obtained, we now know that x plus 1 is a factor of f of x. So we now have to divide the polynomial f of x. So we say divide divide f of x by x plus 1. Of course, we know what our f of x is. So we use the division of polynomials for that. So we have x to the power of 4 minus 2x. Okay, I'm going to introduce a third power and a term in power of 3 to make the distribution of the quotient seamless. Okay, so we have 2x squared minus what again? 3x, then minus 2. We divide that by x plus 1. So we want to see what the second factor will be. So what we're going to do now is to say x divided by, okay, how many times can x go in x to the power of 4? I think that would be x to the power of 3. Then we are using the idea of long division, okay? So x to the power of 3 multiplied by x will give us x to the power of 4. X to the power of 3 multiplied by 1 will give us x to the power of 3. Sorry, x to the power of 3 multiplied by 1 will give us x to the power of 3. So we minus that, this and this will give us 0. And then of course we have minus x cubed. Then we bring down to minus 2x squared. So once we bring down minus 2x squared, we now see how many times can x go in minus x cubed? That will be minus x squared. So this, we multiply this, that will give us minus x cubed. Then minus x squared multiplied by plus 1 will give us minus x squared. So subtract that, this and this will go, and so we have minus x squared, and then we bring down minus 3x. We go again and say x will go in x minus x squared, that will be minus x. And then of course what we now have is we're going to have minus x times x, that will give us minus x squared. Then minus x times plus 1 will give us minus x. And so once we subtract that, we're going to have this and this will cancel out. So we have minus 2x. Then of course we bring down minus 2. So we go again to divide. Minus 2x divided by x will give us minus 2. And then of course minus 2 times x will give us minus 2x. And minus 2 times plus 1 will give us minus 2. So the remainder is 0. So it means that when f of x is divided by x plus 1, the result will be x. So the result now is x to the power of 4 minus 2x squared minus 3x minus 2. When divided, we factorize into x plus 1 bracket x cubed, yes, minus x squared minus x minus 2. Now we go again and use the same method of factorization or finding the zeros of the polynomial to divide the term in cube. So once we do that, we are going to obtain some very interesting results. So what I'm going to do is that I'm going to skip that particular step. So I want you guys to do it and get me, tell us what you obtain. So in going through that, what I found out is that I'm going to get this particular so this one now was further factorized. This once I use the same method, determine the zeros of the polynomial of this cubic polynomial, then we found out that I discovered that x minus 2 is also a factor, and then so factorizing this will give me x minus 2, then x squared plus x plus 1, using the same method I applied here. So at the end of the day, so we can now confidently say that this don't forget that f of x is equal to 0. Therefore, we can say that x to the power of 4 minus 2x squared minus 3x minus 2 equal to x plus 1 multiplied by x minus 2 multiplied by x squared plus x plus 1 equal to 0. So what this means is that x plus 1 equal to 0, or x minus 2 equal to 0, or x squared plus x plus 1 will be equal to 0. Now, from here, x will be equal to minus 1, or x will be equal to 2. Then this particular one, by the time we use the, so from what we've just done, we discovered that from what we've just done now, we notice that x equal to minus 1 or x equal to 2. Then the third factor, which is now quadratic, is going to give us a complex solution. The values are not real. So whereas we are actually interested in the real numbers, in the real roots, okay? So this one will give us complex. So on further check, once we apply the quadratic formula here, we notice that b squared minus 4ac will give us b squared minus 4ac, that's the radicand, is going to give us 1 squared minus 4 times 1 times 1. So which will give us 1 minus 4, which is minus 3. Yes, minus 3. So that means that the roots for this will be x equal to minus 1 plus or minus square root of minus 3 over 2. So this is not the solution we are looking for. So we do with this, we reject this, okay, this is rejected, and then we just focus on the real values. Now let's go back and see, don't forget, x is minus 1 or x is 2, whereas this other factor is complex. So now what we need to do is to come back here and say, there are two cases now. We come back to say case 1, when x equal to minus 1. We know that 2 to the power of a is equal to x. So 2 to the power of a will be equal to minus 1. So this is negative. There is no way the 2 to the power of a number can never be negative, okay? So we also reject this solution, rejected. Now let's go to case 2. Case 2 is where we have x equal to 2. And if that is the case, then 2 to the power of a will be equal to x. So that 2 to the power of a will be equals to 2 to the power of 1. So both sides have the same base, therefore the powers will be equal, because we have, if a to the power of x equal to a to the power of y, therefore x will be equal to y. That means if the bases on both sides are the same, then the powers have to be the same as well. Therefore, our value of a to satisfy that rational exponential equation will be, so if we now will be equal to 1. So let's do the check. Let's check it and see that our answer is correct. So we have 16 to the power of a plus 4 to the power of a plus 1 over, what do we have as our question? Over 4 to the power of a plus 2 to the power of a plus 1 equal to 3. So let's see if this value of a equal to 1 satisfy the actual rational function, the rational exponential equation. So our a is 1, so we have 16 to the power of 1 plus 4 to the power of 1 plus 1 all over 4 to the power of 1 plus 2 to the power of 1 plus 1 equal to 3. So 16 to the power of 1 is 16, 4 to the power of 1 is 4, then plus 1. That will give us 4 to the power of 1 is 4, plus 2 to the power of 1 is 2, and plus 1 equal to 3. So let's see. So let's see if this is 21 all over 7 equal to 3. That means 3 equal to 3. So this is correct. So therefore, we can conclude and say, by saying that a equal to 1 is the actual value of this rational function. Thank you guys for staying by. I'll see you in my next video.